Let's take a look at question number 5. A man is standing on the edge of a 20-meter high cliff. He throws a rock vertically with an initial velocity of 10 meters per second. How high does the rock go? So, we're going to do more and more pictures in our class. So let's start with a nice diagram. We're on a cliff. This cliff is 20 meters tall. Okay? And someone is standing at the top, throws a rock upwards at 20 meters per second. So 20 meters per second up. And we're looking to see how high does this go. So we're going upwards, and it's going to reach some point where it can no longer travel up, and it's going to come to a stop and fall back down. So let's write some givens. For this part of the problem, the height of the cliff is not really important. So we need to know its velocity initial, which is 20 meters per second. We also need to know that when falling objects reach their maximum height, their velocity goes to 0. So we have 0 meters per second. All free fall objects are experiencing gravity at negative 9.81 meters per second squared. And they're asking, how high does this go? So displacement is our unknown. And using our reference table, we can see that the formula v final squared equals v initial squared plus 2ad will help us. We have final, we have initial, we have acceleration, and we're looking for our distance or displacement. Some people might see displacement and default to the displacement formula, d equals v initial t plus 1/2 at squared. And I hope you can see why that's not a good choice for this problem, because right now we don't know t, and without t you wouldn't be able to solve for d, so let's not use that one. Okay, so we have our formula. Let's substitute in the things that we have. Our final velocity is 0. Our initial is 20 meters per second squared. Actually, both of these are squared, even though 0 squared will be 0. 20 meters per second squared plus 2 times negative 9.81 meters per second squared, and d is our unknown. So we can do a little bit of math. 0 times 0 is itself 0. 20 times 20, 20 squared is 400. Okay. Then we're going to have a negative, and 9.81 times 2 is 19.62 d. Okay. And I just want to point this out. This is an error that I've seen some people make. You think that you can do 400 minus 19.62. Don't forget, from algebra, we know we can't combine these because they're called unlike terms. So this second term has a variable attached to it. So you can only combine terms that have the same variable. So no variable can't be added or subtracted from something with a variable. So we have to get the 400 on the other side of the equation. And now we have a negative 400 on the left equals negative 19.62 d. And now we can divide by 19.62 on both sides. Okay, and that 19 divided by 19 is 1, so that is gone. And we can use our calculators, and 400 divided by 19.62 equals, negative divided by negative, we get a positive 20.32 0.39. And that's meters since we're looking at displacement. Why did I put that positive? I'm emphasizing that displacement has a direction. And we started at the top of our cliff and we've gone up a certain distance. And since it's an upward distance, we get a positive answer. So that's a good thing. So how high does the rock go? Well, the rock will go 20.39 meters above the top of the cliff. So some people might say that's the answer. That's how high it's gone above the man. Some people might say, well, yeah, that's how high it is above the man, but that's not the height from the base of the cliff. That's true. So you could also, if you wanted, give an answer of 40.39 meters if you were talking about height from the base of the cliff. I think both of those are good, acceptable answers.